Previously, we talked about what happens if I get things in my eyes and how can I prevent it. Well, I wear goggles. That's what I do. That makes common sense. It helps protect your eyeballs and you won't go to the hospital because of it. So now we need to talk about another route of exposure. And that route of exposure is called inhalation. Did you inhale? Yes or no? If you're going through the trouble of it, I hope you did. All right, so inhalation, inhaling, or basically breathing in a chemical that will eventually make it to your lungs. That is what we are worried with here. Lungs. Once it gets to that part, then certain things can happen with the chemical itself. All right, so we need to talk about what types of chemicals do I not want to breathe in, or do I at least look at and second guess without knowing anything about it. And the very first type of chemical is a very volatile one. Volatile is a word that you keep seeing me use over and over and over. And the reason is because many people have a misconception about what the word volatility means. People think that it means to blow up, and it does not. Volatile means that it evaporates very easily. So what I like to use as an example here is fingernail polish remover. If you squirt fingernail polish remover or acetone, sometimes is used, on a countertop, it's going to evaporate very quickly. That is called a volatile chemical, and that's the proper definition of volatile. Okay? So, it is a change that takes the liquid into a gas. It changes into a gas very easily. So if I've got a bottle and that cap is open and that chemical is a volatile chemical, I've got fumes that are coming from the top. And those vapors can be breathed in. You're going to smell it sometimes. Sometimes these chemicals will have no odor. You will not know that you're breathing it in. Sometimes you will smell it with just a little bit of that vapor in the air. And sometimes you will smell it, but it's going to take a large amount of that vapor that's in the air. That depends on the chemical itself. So anything that is labeled as a volatile chemical, you want to pay special attention to. If it is volatile, what you want to do is make sure that you use a fume hood. If you have any doubt at all, you need to use a fume hood with these chemicals. So a fume hood is basically a box, and there's a sash on the front that can lift up and down. And then you could come over to the fume hood and you could put your chemicals and whatever you're deciding to use down here in the very bottom. And if they are volatile, then these fumes will go up underneath the fume hood. And this fume hood is meant to take these fumes up and out of the room as long as they're on. So when you work with volatile chemicals, if you are worried about exposure, you need to make sure that a fume hood is being used. This will virtually eliminate all of your concern. Not every single time, but virtually every single time, with the minor exceptions. A fume hood will prevent your exposure to that chemical. If the chemical does create fume, some type of vapor, that chemical is now in the air. All right? Air is a mixture. It's a mixture of different compounds. Oxygen is only one of those. You've got oxygen, you have nitrogen, you have argon, you have carbon dioxide, you have a whole slew of different stuff. There are different types of mixtures that you might run across in a laboratory. One of these is called a homogeneous mixture, and one of these is called a heterogeneous mixture. Homogeneous and heterogeneous mean two different things. Homo means the same, hetero means different. So a homogeneous mixture looks the same or is the same from top to bottom. We typically call it throughout. And heterogeneous means that it's different from top to bottom, or it looks different throughout. Well, if I'm using chemicals in a laboratory, and these chemicals are volatile, and they're producing vapor, and that vapor is going into the air, all of a sudden, I have a different type of mixture now on my hand. Depending on the type of molecule that has been released in the air, I have different terms that I can use. If it is a large particle, and by large particle, we're talking about 100 micrometers. Now remember, what is a micrometer? Okay, well, 1 meter is the distance, typically, from your foot to your waist. That is about a meter. A micrometer is 10 to the negative 6th. A millionth of a meter. You can imagine how tiny that is. But if that particle that has been released from that liquid is around 100 micrometers, the definition, the proper definition now of that substance that we're referring to is a colloid. It's a larger, almost solid particle that is escaped into the air. Because it's a big particle, we can't really call it a gas. We can't really even call it a liquid. This is now shot off into the air that I'm going to breathe in. And this, by definition, is called a colloid. The same thing actually happens in a liquid. If I have a solid particle that goes into a liquid, and that particle is bigger than 100 micrometers, then I get these fully solid particles that are swimming around in that liquid. That is also called the colloid. Two immiscible liquids. Just to introduce more terminology here. Immiscible means that it does not mix. Sorry, two liquids don't mix. Water and oil. Those things are immiscible. If I put those two liquids in a container, they're going to separate. Water and oil. Well, if these two liquids I put into a container that they will want to separate over time, and let's say that I add something else to it, like a chemical that maybe is a vapor that comes into the liquid solution or into the sample, and I shake that thing up, it's going to hold these two immiscible liquids together. That is what we would call an emulsion. Think of it almost like Italian salad dressing. We have two immiscible liquids, oil and water, a little bit of vinegar maybe, right? And then I throw in all this other stuff, and if I leave it sitting on the shelf or on the counter, it's going to separate on its own over time. But if I take it and if I shake it up, there's an emulsifier in it. And that emulsifier will take these two immiscible liquids, briefly mix them together, briefly keep them together, and we pour it on our salad leaves and we eat it. Otherwise, you would just be eating pure oil or pure water and vinegar. No one wants to eat that. Mayonnaise, in a way, is almost like an emulsifier as well. All right, so there's two terms, maybe three terms that are possibly new to you. A colloid, what the term immiscible means, it doesn't mix, and what the term emulsion means. So let's keep trucking on. We're on a roll. So let's keep introducing new terms that we can pull into the play here. The next one is a mist. We're talking about volatile liquids here, right? And volatile liquids are going to produce vapor. Well, a mist, think of an amusement park. It's a hot summer day, maybe at Carowinds. You walk down the sidewalk, you go under a covered area, and there's that nice breeze with that fan blowing and all of that cold mist falling on top of you. People will huddle under these contraptions for minutes at a time just to cool off. Well, mist can happen in the lab. We've got to give it a definition, right? And we're going to say that these are tiny little droplets of liquid in the air. So this stuff is volatile. It can escape. It can go into a gas form. But, if it's given the right circumstance, I can disperse this liquid into tiny little droplets that's going to take up space in the air that I breathe in or in the air that falls on me. And that is called mist. Mist can happen in the lab. That is a route of exposure because I could breathe in that mist, right? It could also fall into my skin. That's another route of exposure. But here we're talking about breathing in, inhalation. Smoke. Smoke can happen in the lab as well. Smoke is basically liquid and solid particles that are in the air. Think of you cranking up your grill with some charcoal on the 4th of July. You're going to light the charcoal up. You're going to see it smoke. You never put the burger meat or the hot dog meat onto the grill as long as it's a flame. That could cause cancer. You wait till the flames go out. Then you're left with the smoke and the residual heat. That is what you use to cook your food with, or that's how you should be using charcoal. So that smoke that's getting created from the charcoal briquettes, that is a mixture of a liquid and solid particle. And more than that, smoke typically comes from what we call the incomplete combustion of carbon-based material. So a tree trunk is carbon-based. I can light a tree trunk on fire. That's going to create some smoke. That smoke is basically a mixture of air and smaller particles of liquids and solids that are all mixed together. An homogeneous mixture. A house can go up on fire. A sheet of paper can go up in flames. All of that is carbon-based. All of that creates smoke. Your candles at home, when you blow them out, that's incomplete combustion of a carbon-based material. You've got the wax and you've got the wick. That's going to create some smoke. That smoke can be breathed in, and you have just incorporated a route of exposure. That's something else that we want to look for in a laboratory, right? Not just the chemical itself, but the smoke that can be produced from that chemical or from that reaction. Fumes. Okay, how is a fume different than anything else that we've talked about? These are colloidal suspensions almost every single time. That means that these are larger particles, greater than 100 micrometers, of solids or liquids. The key, though, is that they are larger particles. And finally, dust. Dust is also something that we have to look out for, because this is basically solid particles that are in the air. It doesn't have to be a liquid every single time. So a solid basically can be so lightweight that it can go up into the air and you can breathe in that solid particle. We call that dust. If you've ever cleaned your house, you know what dust is. And I hope you do clean your house. So what does all this mean? All of these are different things that I need to take care of. I need to think about. I need to maybe learn about how not to expose myself to these types of things. But what is the takeaway message? What can I learn from all of these terms? Well, number one, very small particles stay in the air for longer periods of time. Smaller particles can also go into your lungs. And if they're small enough, they can actually stay there. So the smaller the particle, if I breathe that in, my exposure could be very great. My exposure could also be long-term, because even after I leave the room, those very tiny particles are already in my lungs. And they will stay there when I get home. They could stay there the next day. They could still be there the following week. And I want to make sure that I prevent those extremely tiny particles from going into my lungs and contaminating myself for maybe forever. We'll compare that to large particles. Large particles typically stay in the air a much shorter time than smaller ones do. Not only that, but these larger particles typically do not make it to the lungs. They stop at the nose. And you pick them out and you make boogers with them. Well, I hate to say that, but that's kind of what it is. So if you're in your house and you're cleaning and there's a lot of dust and you're basically putting all that dust into the air and you're breathing it in, well, later on that day, depending on how dirty or nasty your house is, you're going to blow out boogers and they're going to be black and brown. It's one of the reasons your nose has prevented those larger particles from making it to your lungs. The same way if you're outside at a charcoal grill. If you're staying around the grill and you're breathing in all that smoke, those smaller liquid and solid particles that are in the air, you're breathing that in, and then at night you go and you pick a booger out or you blow your nose, you're going to automatically know where that color's coming from. Some particles, though, are so small that your nose cannot stop the exposure. And those particles go on into your lungs And now your lungs will have to take care of themselves. Something else that I want to talk about with the large particles here. The large particles can go into your nose, but your nose is connected to your throat. Honk out some loogies, right? All right, well, all of that drainage can happen. It's all connected. So if there's larger particles, not only have you basically exposed yourself to inhalation, but it can also be ingestion. You can actually suck that stuff in. It can go down your throat, into your mouth, and down into your stomach. I hope you don't eat boogers. But that's basically what I'm talking about here. So you don't want to sniff it in and then swallow it and make that horrible loogie noise that you hear people do, especially on a hot summer day when they decide to spit on the sidewalk. All right, so that's where this video is going to stop. We've talked a little bit about liquids. We've talked a little bit about solids, how they can be incorporated into the air, and basically inhalation. So we're going to pick up with this topic in the next video. We're going to continue on, and we're going to talk about the other routes of exposure.